Welcome to amieacademy.com. In strength of materials, let us discuss about helical springs. Helical springs are the thick spring wire coiled into a helix. They are of two types: closed coil helical springs and open coil helical springs. Closed coil helical springs are the springs in which the helix angle is very small, or in the other words, the pitch between two adjacent turns is small. A closed coil helical spring carries an axial load as the helix angle in case of closed coil helical springs are small, hence the bending effect on the spring is ignored, and we assume that the coils of a closed coil helical springs are to stand purely torsional stresses. Helical springs is a mechanical device which is typically used to store energy and subsequently release it, to absorb shock, or to maintain a force between contacting surfaces. They are made of an elastic materials formed into the shape of helix, which turns into its natural length when unloaded. Here is a cross-sectional area of helical spring. Look at here. This is a mean diameter of the helical spring. This is a free length L0, then coil angle alpha, and this is a pitch, is a wire diameter. Now there are two types of helical spring: is there closed coil helical springs and open coil helical springs. Now expression for maximum shear stress induced in wire. We'll express this first. Here let d equal diameter of wire, diameter of spring wire, spring wire. P equal pitch of the helical spring. N equal number of coils. R equal to mean radius of the spring coil. R equal to mean radius of which is d by 2, diameter divided by 2. W equal axial load. Axial load. Now C equal modulus of rigidity. Modulus of rigidity. Tau equal maximum shear stress. Maximum shear stress induced in the wire. Theta angle of twist. Angle of twist. Angle of twist, that is in spring wire. Delta deflection of spring due to axial load. Deflection of spring due to axial load. Then L equal length of the wire. Now twisting moment. That is twisting here due to due to load, its twisting load is created. Due to axial load, twisting load is moment is created. Therefore, twisting moment on the wire equal T equal to W R. Axial load into the radius of the coil, radius of the spring. But twisting moment also is equal pi by 16 tau dq. Then both are equating. WR equal pi by 16 to dq. From that, tau equal 16 WR over pi dq. This is shear stress. But the equation maximum stress induced in the wire maximum stress induced in the wire. This is a maximum stress induced in the wire is 16 W R over pi dq. Next, expression for deflection of spring. Now, length of one coil. One coil is pi d because circumference is equal to pi r. Total length of the wire. Total length of the wire, the spring which is made by the wire is number of coils, that is L equal 2 pi r into n because number of turns. As every section of the wire is subjected to a torsion, look at here, due to axial load, every section of the wire is subjected to twisting load, torsion. Therefore, strain energy stored. Strain energy stored is U equal tau square over 4C into volume, which is equal U equal tau is 16 WR over pi dq we expressed already, that is here, into 1 over 4C, that is here tau square over 4C is here this, and the volume is pi by 4 d square, square of the diameter of the wire, and 2 pi r n. Here, this is the cross section and total length is volume here. Therefore, by simplification, u equal 32 w square. Here, after simplification, w square r square over c d power 4 into r n, which is further equal 32 w square r cube cd or 4 into n. This is strain energy stored. Now we know that work done on the spring. Work done on the spring is average load into deflection of the spring due to axial load. Here, that is, average load is half W is average load into deflection is delta, which is equal strain energy stored. That is what done. Here, 32 W square R cube n over C d power 4. From this, delta equal, by simplification, with 64 W R cube into n over C d power 4. This is a deflection of the spring due to axial load. Next, expression for stiffness of the spring. Stiffness of the spring is S equal load per unit deflection. Stiffness is equal load per unit deflection, which is equal W over delta, which is equal W. Already delta we expressed. That is, we have to substitute that one. 64 W R cube n over C d power 4. By simplification, we get stiffness equal C d power 4. This go up over W will cut and 64 R cube n, the stiffness of the spring. So far we discussed about stiffness of the spring, strain energy stored, and deflection, and further we discussed maximum stress induced in the wire. We have done. Please subscribe our YouTube channel.